two part on vectors is going to be about lines and planes, okay, in three-dimensional. Okay, so maybe before we start, I just want to give you a representation on how lines are like, right, in a three-dimensional space, even though I'm still drawing in a two-dimensional space. Okay, Z is going on top, X is coming in front, okay, Y is over here. Okay, so a line, okay, in a three-dimensional space is like this. That means a bit hard to visualize because it still looks two-dimensional, right? Yeah, this guy could be lying on the XY plane, so that means this could be like 1, 0, 1. And then this guy could be lying on the YZ plane, and that would be like 0, maybe 2, and then 4, something like that. Okay, not the most accurate. Okay, so in this way, so you see a line, right? Then another line could be, you know, coming over here this way, and it might not they might not necessarily intersect. They might be all on top of each other with another point and another point. Okay, so these are lines in a three-dimensional form. Okay, so first to understand, we have two kinds of vector. We can have two kinds of equation on a line. The easiest way to form equation on line, right, is using the vector equation. Okay, so first, number one, in this chapter, I want you to remember R means x, y, z. Okay, when you see the word R means x, y, z. So a line is represented by R equals to basically x, y, z equals to, but we represent it by R. OA, which is a point, okay, plus a direction. Okay, so you need a point and a direction. So always just remember, take a point and a direction. The point must be on the line. So A can be the point. AR can be the direction. So I don't like to use M, I would like to use D, is better. Okay, so a point and a direction. So the direction could be AR, could be RA. So it doesn't matter, which means that you will not have there will not be a unique answer for an equation on a line. Okay, so this equation of this line that passes through, so this point 2, 5, 1, as well as this point 1, negative 1, negative 2, okay, is going to be as such. I know that you can take either of the points. So let's take the direction. Direction is a vector. It will be 2, 5, 1 minus 1, negative 1, negative 2. Okay, and that would be equals to 1, 6, 3. Okay, 1, 6, 3. So I can have my line L such that R equals to, I take a point 2, 5, 1. Okay, plus lambda. The direction is 1, 6, 3. Okay, it could be 1, negative 1, negative 2 plus lambda 1, 6, 3 as well. Okay, so either any of the points plus one direction vector will do, and you can get, this is called the vector equation, okay, of the line. So next part, Cartesian equation means in terms of x, y, z. Okay, basically the concept is just to make lambda the subject. Just make lambda the subject. Yeah, sometimes your vector equation may not have lambda, have maybe plus mu of something, then just make mu the subject. Okay, just make lambda the subject. And remember, R equals to x, y, z. Okay, so all you need to do is, yeah, as long as you know that R means x, y, z, right? You just put this x, y, z is equals to, these two can combine together to become 1 plus 2 lambda, 2 minus lambda, as well as 1 plus lambda. Okay, equation 1, this means that x is equals to 1 plus 2 lambda, isn't it? So I make lambda the subject. Lambda is equals to x minus 1 over 2. Y, so this is the x, this is the y, and then this is the z. These are three different equations. Y, 2 minus lambda. Lambda equals to 2 minus y. Okay, and z equals to 1 plus lambda. So lambda equals to z minus 1. Okay, if all these three are equals to lambda, what does it mean? They are equal. X minus 1 over 2 is equals to 2 minus y, or is equals to z minus 1. Okay, and that it would be the Cartesian equation, okay, of this line. Now sometimes, right, there could be 0 lambda. So for example, let's say I use the same example, but instead of okay, so this is like 1, 2, 1 plus, okay, I use mu, 2, negative 1, 0. Okay, so you look at the z. The z is equals to 1 plus 0 lambda, right? Sorry, 0 mu, right? So basically, there's nothing here. Then in this case, if there's 0 mu, then it will be represented by the x and the y are still the same. 2 minus y, right? Then comma, z equals to 1. So when you see this one, right, this means that the lambda or mu is equals to 0. Okay, now. Okay, so this means that the point is just there. Now, if I want to convert it back, then it will be the same thing. Okay, I want to convert it back, it will be the same thing. For example, in this case, I already put down here, over here. Okay, if I want to find the vector equation, I let each of them equals to lambda. Over negative 6 equals to lambda. So x equals to minus 1 minus 6 lambda. Can see? Yeah. 1 minus y equals to lambda. Y equals to 1 minus lambda. Okay, then the last one will be z is just equals to 2 plus, okay, you can want to write plus 0 lambda also can. So now we put everything together. R equals to minus 1 minus 6 lambda, because R means x, y, z. Okay, 1 minus lambda as well as 2 plus 0 lambda. So all you need to do is to split them up. Okay, the point negative 1, 1, 2. Okay, plus lambda. Okay, that means I split this up into this part. This guy is the point, and then this guy is the direction. So take out the lambda, I will have negative 6, negative 1, and then 0. Okay, this is fine, but I would always like to do the direction vector in positive form. So 6, 1, 0, it will be better. So this is the vector equation of the line if I want to convert from Cartesian equation. Okay, so remember that number 1, equation of the line is found by having a point and a direction. So the point can be either of the points you have. The direction need not be on the line, it could be just parallel to something. You can also use it. Okay, so a point plus lambda direction. Number 2, if I want to convert from a vector equation to a Cartesian equation, I just remember that r is equals to x, y, z. Then I make lambda the subject, then I can equate all of them together. And number 3, if I want to convert from vector equation to Cartesian equation to vector form, I just let all of them equals to lambda. I make x, y, z the subject because r is equals to x, y, z, and this is a very basic concept that students do not understand or digest, that r means the general form of x, y, z, and it can be represented in a line or on a plane. Okay, so this is the first basic part of vectors on a line.